us move on to the chemical properties of carbon compounds. Now we have studied the physical properties of it. Now let's move on to the chemical properties. So we already know that carbon compounds are very easily burnt because we know we use coal as a fuel source, and our petroleum products has uh, content in it, too much carbon content in it. So the first reaction we will be going to study in chemical properties of carbon compounds is combustion. So what is combustion? Combustion is burning of carbon. So you can see here carbon, when it is burnt in the presence of oxygen, it releases lot of carbon dioxide, and along with it, it produces heat, also light. So you can see why this reaction is already known to you. You studied it in oxidation chapter, oxidation part of the chapter. So here, what is happening? Oxygen is going and attaching to carbon to produce CO2. So carbon is getting oxidized. So are all the other compounds. Here you can see CH4. So what is the name of this compound, students? Of course, it is methane. So CH2, if you burn CH4, if you burn in the presence of oxygen, you get CO2 and H2O. That is carbon dioxide and water. So water goes in the form of steam, so you cannot really get water out of it. And also there is production of heat and light. So please try to name this compound, and it also gets oxidized by oxygen, and if you burn it you get again CO2 plus H2O with heat and light. So
Register today at KLM Institute for free online classes, revisions, doubt clearance, private online and offline classes, Olympiad exams, and win prizes, scholarships, and much more.
So what happens when you burn different types of carbon compounds, such as here you can see CH4, pure CH4 burning, and this is probably some unsaturated compound, and this is again CH4, and this is a highly unsaturated compound. So why am I telling you all this? Because you can see there is a difference between these flames. You can see this is a nice blue flame here in this picture, but this has a yellow flame, and this has a blue flame, then it becomes a yellow flame. So what is happening here? So saturated compounds such as CH4, you can see CH4, right? This is methane. So when you burn methane, it leads to clean, and it burns completely to produce CO2 and H2O. So you cannot see any of the yellow unburnt carbon is not seen. When carbon is unburnt, that it does not get enough oxygen, it burns like this. In the picture 3, you can see here. Let's name the pictures 2, 1, and 4. So in the second picture, what is happening? Wax or oil. If you have in Diwali and all festivals, we burn a oil lamp. So it gives us yellow and sooty flame. So what is soot? If you put a vessel or a steel plate on it, you get a black carbon residue. You get a sooty flame in presence of oils because it contains unsaturated fatty acids or unsaturated carbon compounds. So this is what is happening in the second picture. You can see the example of this soot here in the fourth picture. So this is probably a unsaturated hydrocarbon or a carbon compound which is burning with less oxygen. If you give it more oxygen, it has a chance of burning with blue flame, clean blue flame without any soot. So that is about the combustion. So when we talk about combustion, we like to talk about the most combusted product, that is we use the most, called as petrol or diesel. All these products such as petrol, diesel, kerosene are petroleum products. So they contain trace amount of nitrogen and sulfur. So when you burn them, it does not just produce water and carbon dioxide. It produces oxides of nitrogen, it produces oxides of sulfur. You have already studied oxides of nitrogen and oxides of sulfur are very harmful, and it causes acid rain in the nature. So these compounds are, that's why we need emission test. So in the vehicle, if the engine is insufficient to filter these compounds, these harmful compounds, that vehicle should not be allowed to move in the vicinity. So this is about the petroleum products. So that is not only the one way of oxidizing carbon compounds. So you can see here we take ethanol. So ethanol is CH3, CH2OH. We add alkaline KMNO4 and heat it, or we add acidified K2CrO7, okay, and heat it, we get ethanoic acid. So what is happening here? You can see, let's draw ethanol, okay, C and OH. So here we have three hydrogen atoms, and here we have two hydrogen atoms. So please try to practice all the structures, whatever name anybody tells, try to write the structure of it so that you get perfect with it. So what is happening here? Here to this carbon atom, we are adding oxygen. So hydrogen is, two of the hydrogen are replaced by one oxygen. So what does it become? It becomes CH3COOH. So this is ethanoic acid. So the functional group has changed here. What was the functional group here? It was an alcohol. Now it has become an carboxylic acid. So why are we adding alkaline KMNO4 or acidified K2CR2O7? So these are known as oxidizing agents. It is ready to give oxygen to the compounds. So these compounds are substances which are capable of adding oxygen to other compounds or molecules are known as oxidizing agents. This is very helpful in the further classes. Okay.
Give your imagination wings. If you're willing to write something, what are you waiting for? Share your ideas and thoughts. Let your ideas reach out to millions. Get your articles published through our blogs for free.
Now let us move on to the addition reaction. So what is addition reaction? We have already studied it in chemical reactions and equations. If you haven't watched it, please watch it. We have in our channel. So addition reaction is adding something to a compound. So let's see what are we adding here. Unsaturated carbon compound. What do you mean by unsaturated carbon compound? That it contains a double bond. So when it contains a double bond, it tends to react vigorously. So we add something known as nickel catalyst. So in the presence of hydrogen gas, it forms, you can see here, one R group. This double bond breaks here. Okay. this double bond breaks and becomes a single bond. So from unsaturated, we are converting it to saturated compound. Why are we doing this? Where is it used? It is used in our saturation of our fatty acids, in our oils, or in cheese. So cheese is mostly, you can see here, cheese is 20 grams out of 30 grams is saturated fat. So studies have shown that saturated fat is not that good for your health. So try to eat oil or fat which is unsaturated, such as this is the nutrition facts in an oil packet. You can see polyunsaturated fats and monounsaturated fats is high compared to saturated fats. So try to use this kind of oil. This research shows high intake of saturated fats can lead to obesity very quickly. So that is about the addition reaction. Now let us move on to substitution reaction of carbon compounds. So it also shows, we will draw a methane molecule here. Okay. So this is a methane molecule. If you react it with chlorine, what happens? Now chlorine gets separated. You can see here. Let's not draw the chlorine atom like this. Cl2 will be in the form of like this. Cl bonded by Cl. So what happens will, yes, here these two have a tendency to attract each other because Cl needs one electron and hydrogen needs one electron. They form a covalent bond together and forms out HCl. They come out as HCl. So what about this Cl then? This Cl and goes and attaches to the carbon atom. So it becomes, this compound becomes CH3Cl, that is chloromethane. So this is substitution reaction. One hydrogen is getting replaced by one chlorine molecule. So it happens only in the presence of sunlight, students. Without sunlight, this reaction is not possible. So we can see that as you go to higher classes, you can see substitution reaction is very common in carbon compounds because hydrogen is very easily replaceable as it is containing, the carbon is holding 4 molecules of hydrogen. So it is ready to give one and make a new bond formation.